And so I guess the story I want to tell, which is a nice wrap-up of the session and the previous session, is what to do with the data in terms of how do we create a market, how do engineers play in it, and what are the legal implications? And we're from people from the law school. We've lots of engineers today, some people from business and economics, so I think that will be a nice wrap-up. I would like to illustrate this in the specific context of one project we did and then try to broaden this. So sensors and sensor networks, that's the title of the session today. In my field, in transportation engineering, that's what a sensor network used to look like for the last 40 years of our life, right? So things which are self-inductive loops in the pavement, there's thousands of them in California, cameras, stuff you put in your car. The curve on the right here is quite astonishing because you can see an almost vertical line, and that's the curve of smartphones in 2011. That one is completely off the roof now and off chart. And so the next sensor in traffic, like in almost every field now, is a cell phone. It's particularly remarkable in the case of traffic. If you remember vintage websites in 2008 for looking at traffic, this is what it would look like. You probably don't even remember. That's the vintage internet. So this on the right is what we created in that project. And of course, now you have it on Google, you have it on Apple, you have it on Inrix and every other possible traffic provider. The main difference between these two graphs being that the data, which is in the secondary network, so not the freeways, for those of you who are familiar with the Bay, comes from smartphone. For the record, our group was the first group to deploy an app to do that on RIM and Symbian smartphone to be deployed in North America. It was before the iPhone had a GPS. And of course now, the amount of data collected by every possible provider of mobile services is astonishing, and anybody, in fact, can do that. This is a sense of, at the time, back in 2010, when we were collecting that data, what one day of data would look like for San Francisco. So each of the dots here corresponds to one GPS point of a taxi collected roughly every minute, and this was 0.5% of what we got. The data that Google, Apple, and such companies have is probably on the order of 10,000 or even more time what you see here. So this is, bottom line is with one day of data, you can draw the map, you can monitor traffic in real time. Just for taxis, you can see how far they're going and the level of accuracy with which you can distinguish if people are flying international business or whatnot, depending on which exchange they go to the airport, is showing so much for privacy. Okay, so this completely changed the field of transportation, and this completely changed a lot of other fields we've heard about today. So now, there's a lot of engineering challenges with this data. I'm just going to show one here, so you see the job of using the data is actually quite hard. This is an example of successive locations provided by a taxi in San Francisco. Taxi in 1 minute can go up to 7 blocks if they're really in a hurry, or you're really in a hurry. But when it stops at a stop sign because of GPS error, a position later in time could actually be behind just because of the noise. Now, you can imagine that a smart algorithm will assume you went around the block. Of course, you didn't. You were just waiting, and that's noise. So I just want to show that simple example to show the difficulty of dealing with that data. That data is everywhere. It's enormous, but the challenges in using it are quite significant. This is an example of what that data looks like if you plot it as a function of time and location. So with that, you can basically read, you pick any point, pick the color that tells you the level of congestion. Okay, this is if 2% of the vehicles have a phone. In the US, in California, it's already above 98%. Okay, so bottom line is you can read that data. The problem is nobody has it all. And so in practice, what you end up with is more something like this, because the data is in general collected only at specific locations, and you need to reconstruct something like that, which is in a sense a mirror of what the data is had you all the data. So you can see the difficulty, the engineering difficulty here. And that brings me to the main topic of this talk, which is, okay, so this data is being collected by virtually dozens of companies around the world. Now, what do we do with it? How do we create a market for it? And that's where the difficulty begins. So say I'm a public agency, the Department of Transportation or any other public agency, and I want to buy that data. Well, in the history, I have never bought that data before, so I don't know if I buy that data. You buy GPS by the kilo, by the pound, and how much you price a pound of GPS data. So there's no procedure. And also, how do I know it's good GPS data or bad GPS data? You go to the market, you can see if the tomatoes are rotten or the banana is completely black. Well, with GPS data, it's hard to say. this is where we academics and scientists come into play, and this is where, in a sense, people who are in the law business, people who are in the economics and business, and engineers have to play together. This is an example of procurement that we created at Berkeley on behalf of the state of California. So the state of California is trying to acquire this data. It's something which is inherently part of its future. And there's no procedure. There's no process. There's not even a technical process to evaluate the quality of the data. And I would say that probably applies to 90% of what we heard today. Okay? Everybody is shown how to collect data. Now try to sell that data, try to create a market with that data for an agency and try to explain to that agency what they should use to price the data. So this was historically the first time this was done for GPS data for traffic, and this was extremely instructive because we showed how you can create a competitive bid. Some people will bid because they want to sell that data. Some people won't. Google will never sell their data. Google will probably never even share their data. So now you have to figure out how, well, except with very specific three-letter agencies, but that's a different story. So the bottom line is you want to create tools that enable these agencies to assess, how much am I ready to pay for a pound of good GPS data? And so how do you assess what a pound of good GPS data is? For example, is the data timely? If you're in the traffic information business, any data that is more than 5 minutes old is rotten because it's useless for real-time traffic information. Now people tell you, I'm going to provide you 1 million points a day. Yeah, right, but if these are only at night because you're monitoring the trucks, well, that's not really helpful if you're trying to predict traffic at 12 a.m., or sorry, at 1 p.m., and so on and so on. So this is kind of our responsibility as engineers. Everybody's excited about building new tools and collecting new data. The next real question is, okay, now that all this data is collected and is in the hands of a hugely fragmented market, how to create the tools to create good pricing and also to create the proper market mechanisms so that the public agencies can benefit from it. Because today, these agencies are in need for it, but they have great difficulties to understand how to acquire it. Now, where is this going? Once this is all done, here's a typical thing that California is trying to do. This project called the Integrated Corridor Management Project is a project which tries to gather all this data, assemble it, and use it to manage its infrastructure better. Here's an example where in the future, California will try to have changeable message signs, ramp meters, smartphone, and advice to go parking when congestion gets too high, work together in a single integrated environment, something which has never really been done in the US because it's too hard to link all these infrastructure together. So you can see that the need, and the reason why I'm showing this is because there's no way a state agency would ever deploy its own infrastructure to monitor this. It's too big if you want to monitor every street and every possible mode of transportation. So for that, you just have to buy data. That means also buying social network data, because, for example, if you take something like Caltrain, today Twitter is the most reliable form of transit information for Caltrain. So it's not even something which belongs to an agency anymore. It's a social network. So Mission 2015 is really to take control of a freeway. So I'm back to my own project now. We're going to take over I-210 in Los Angeles to show that with this type of data and the integration of all this infrastructure, you could greatly improve mobility. You could greatly improve the way that infrastructure is monitored, thanks to all the gadgets and all the great tools that all of the people in this room are developing, because hopefully we could buy it through some market. To conclude with another, maybe 2 slides, one thing I wanted to say is that I'm glad we heard before about earthquakes. Another thing we did was show how cell phones can be used to monitor earthquakes. And I think we've seen cell phones do practically everything today except swimming. So I wanted to show you what a cell phone does when it's trying to swim. This is an example of a floating sensor network we created. So imagine you're trying to monitor the quality of the water. And so, in classical robotics, you would create your own controller and central unit. The point is today you can replace almost every virtual piece of equipment including the sensing in these devices by your smartphone, because with that you have practically everything you need. You have the computational power, you have a positional accuracy. So these are the swimming cell phones. First we try them in the swimming pool at Berkeley because we want to make sure that they can swim well, and when they're trained enough, then we go to a real natural environment where the currents are a bit rougher. So we have a beautiful swimming pool here, by the way, if you're not from Berkeley, you should really try it. It's an ancient Greek style swimming pool. So this is another example of how you can divert, the practical uses of a device which all of us has. This one just took his first dip. And so I'm going to stop with this movie, which is my last slide. This is, it's pretty boring to watch water, just like watching traffic on the internet is pretty boring, so you have to accelerate it, otherwise, you'd be sitting here all day. But here, what I want to show is that, this really opens a lot of avenues, first to have fun, but also for agencies to really change the way they monitor public infrastructure and infrastructure which classically you couldn't instrument. So this is an example of a deployment that we did in the Sacramento Delta in Walnut Grove. And here the challenge is to basically have these, so you can see they're swimming, like this guy wants to go back to the center line, right? They're trying to assemble themselves to kind of monitor in some kind of fashion the currents here. So I'm going to stop here, and I look forward to the panel.